Good morning, everybody. This is Professor Namrata Chandel from Department of Civil Engineering, Metropolis Institute of Technology and Research. In the last part of Open Channel Flow, we have studied the what is the significance of this subject, what is open channel flow, what is the difference between open channel flow and pipe flow, and types of channel, and the types of flow. In types of flow, we have understood about one type of flow, that is steady flow, steady and unsteady. Now I'll talk about the uniform flow and non-uniform. In case of uniform flow, already I have already explained in the part 1. In case of uniform flow, if the if you went to the river and you have taken some section, and that section you have nominated at as AB, at point A and point B, two section you have considered, and throughout that section, if the fluid properties or if the fluid characteristics are not changing throughout the space, if the fluid characteristics are not changing, it is not with respect to time. In case of steady flow, what we have learned, if the fluid characteristics are not changing with respect to time at a particular point, that is steady flow. But in case of uniform flow, if the fluid properties or fluid characteristics are not changing with respect to time, with respect to space, is known as uniform flow. For example, you went to the river side, and you have taken one section, number A and section number B. Section point A and point B. In between that section, you will take the average velocity, you will take the average length, you will take the average depth. Okay. So at section AB, if if you want to take average, means in between section AB, you have selected some points, point number A1, A2, A3, B1, B2, B3, and average. How you can calculate average? You will sum all that point, the velocity at different points, and divided by it will divided by the number of points you have taken. That way you can take the average. So in the river cases or in the canal, in the case of canal, you have to take the mean velocity, you have to take the mean depth. One single velocity will not perform any mathematical, it will not actually explain any mathematical. You have to take the mean velocity. In case of uniform flow, what happened? The fluid characteristic means you have taken point number A1, A2, A3, B1, B2, all that point have the velocity, same velocity. Means the mean will be same. It is an ideal condition. Again, the steady flow is also an ideal condition. It will not exist. It will exist rarely. Can be achieved in laboratory. So, if the fluid characteristics, fluid velocity, fluid depth, flow rate, what do you mean by flow rate? Flow rate means if you have, everybody have tap in their houses. If 10-liter bucket is there, you just open the tap, and how much time is taken to fill that bucket? You have calculated that time. In that time, how much water, how much volume of water occurring through the tap is meter cube per second. Volume of water per unit time. That will give you the discharge. In case of open channel flow, that is also a discharge. How much volume of water occurring in particular point within a second or a unit time, that is known as flow rate. So how much flow rate is there? If the flow rate is constant, if the velocity is constant, that type of flow is known as uniform flow. If it is not constant, it is known as non-uniform. So the uniform flow, again, it is classified as gradually varied flow and rapidly varied flow. In case of gradually varied flow, if the depth of flow in a channel changes gradually over a length of the channel, that type of flow is known as gradually varied flow. And if the sudden change will occur, that type of flow is known as rapidly varied flow. Sudden change throughout the channel. The definition of rapidly varied flow is if the depth of flow in a channel changes abruptly over a small length of the channel. Throughout the channel, not throughout the channel, small length of channel known as rapidly varied flow. What does it mean? Here you can see this diagram. Here, this is the bottom line. Here the flow is taking place. This is the flow direction. You can see here this type of flow where the depth is not changing. Throughout the length of the section, the depth remain constant in case of uniform flow or the fluid properties remain constant. But in case of non-uniform flow, the depth is changing abruptly or the depth is changing gradually. So here you can see the rapid varied flow is a non-uniform flow. Again, it is classified as rapidly varied flow where here the depth is minimum and the depth is maximum. Over the small length of the section, depth is changing abruptly, known as gradually rapidly varied flow. Again, with this diagram, you can see here the depth of flow. This is the depth of flow, and in the previous condition, this is the depth of flow. Over a small length of the channel, the depth of flow is changing abruptly. This is known as rapidly varied flow. This is uniform flow because the depth is uniform in that section. Again, rapidly varied flow. Again, it is the depth is changing abruptly in the small length of the section. And this is again case of uniform flow. In that section also, the rapidly varied flow will occur because the small length of the section rapidly change of the depth is occurring. This is the gradually varied flow. Here you can see gradual slope of the flow. Bottom is constant. Gradually varied flow is there. Suddenly abrupt change is there. And this type of flow is again the depth is constant throughout the section in uniform flow. So you can, I think it is very much clear what is uniform flow, what is non-uniform flow, and the gradually varied flow and rapidly varied. The third type of flow is there, that is laminar flow and turbulent flow. In case of laminar flow, the Reynolds number, you have to calculate the Reynolds number for checking the either the flow is laminar or turbulent. So Reynolds number is a number, dimensionless number. We evaluate the pattern of flow, whether it is laminar or turbulent. In case of open channel flow, the ranges of Reynolds number will change as compared with the pipe flow. Here the formula is rho V R by mu, rho V R by mu, where R is the hydraulic mean depth and it is a ratio of area, the cross section area divided by the wetted perimeter. Wetted perimeter. What do you mean by wetted perimeter? Wetted perimeter means if the submerged area, submerged perimeter, how much water is there, how much uh, depth is there, which is covering the perimeter of that particular section. So, by the density is known, the velocity you can evaluate, the hydraulic radius you can evaluate, and the viscosity is constant. With these parameters, you can find the Reynolds number. If the Reynolds number is less than 500, it means the flow is laminar. If the Reynolds number in between 500 to 500 to 2000, it is a transition state, and if the Reynolds number is more than 2000, this is known as turbulent flow. This is the example of turbulent and laminar flow where you can see fluid particles are running same plane or in the parallel motion. It is not It is not approaching in the next layer. It is still flowing in the same layer, that is known as laminar. And in case of turbulent, particles are approaching to the different layers. It is diffused in the several layers. This is the example of turbulent flow. So this is the formula I have already explained. The laminar, for the laminar flow, it is less than 500. In between 500 to 1000 is known as transition flow, and more than 1000 is known as turbulent. I think it is the reading is, it should be, it is misleading. This is 2000. If the Renault number in between 500 to 2000 transition state, and more than 2000 turbulent state. The fourth type of flow is known as subcritical, critical, and supercritical flow. Where the Froude number is less than 1, the flow is known as supercritical flow. Subcritical flow, sorry. If the Froude number is more than 1, it is known as supercritical flow, and the Froude number equal to 1, it is known as critical flow. Froude number is basically dependent upon the velocity and depth and gravity. If the depth is minimum, the Froude number is maximum. If the depth is maximum, the Froude number is. In case of, thank you everybody.